Welcome to this explainer. Okay, if you've ever stared at a new computer's spec sheet and felt like you were completely drowning in a bowl of alphabet soup, well, you're definitely not alone. We've all been there, right? So today, we're going to decode this tech alphabet and turn all those confusing letters into clear, actionable knowledge. Let's get started. Here is our roadmap for today. We're going to start with decoding the tech alphabet, then move on to hardware and storage explained, check out networking and the internet, look at software and programming basics, touch on emerging tech trends, and finally, wrap up with mastering your tech specs. Basically, we're taking an inside-out journey today, from the physical guts of the machine all the way out to the vast internet and the future of tech.
Okay, let's dive into this with Section 1, Decoding the Tech Alphabet.
Seriously, do computer spec sheets read like a foreign language to you? Because even for total tech enthusiasts, modern spec sheets can honestly look like a cryptogram. Like, are you looking at a minor upgrade here or a completely different system architecture? It is so easy to get lost in all those acronyms when you're just trying to check out the capabilities of a new laptop, a phone, or a monitor.
But here's the thing, mastering these acronyms is incredibly practical. This isn't just about showing off at a tech trivia night, you know? Understanding this computing language is absolutely key to navigating those specs and actually troubleshooting your own devices. When you know what these letters stand for, you are instantly empowered. You're going to buy the exact right equipment for your needs, and you'll be able to quickly isolate those annoying everyday tech issues.
Moving right along, let's get into Section 2, Hardware and Storage Explained. This is where we start our journey by looking at the physical hardware you can actually touch.
First up, the CPU, which stands for Central Processing Unit. Think of the CPU as the absolute heavyweight foundation of your computer. It's essentially the main brain of the whole operation. It acts like the master conductor of an orchestra, just rapidly directing billions of microtasks across your system every single second. Literally every click, every calculation, and every process runs directly through it.
Now, the rest of the hardware basically dances to that conductor's beat. When you press the power button, the BIOS, that's the basic input-output system, wakes the whole system up. Boom. Then your GPU, the graphics processing unit, instantly pushes those gorgeous, high-fidelity graphics right to your LCD or LED screen, and meanwhile, your USB, your universal serial bus ports, are just standing by, ready to connect the rest of your physical world straight to the machine.
Now let's talk memory, because this is a big one. We need to compare RAM versus ROM. They sound similar, but they serve entirely different functions. Think of RAM, or random access memory, as your active, kind of messy workspace. It's temporary memory, it changes actively, and it's where all your currently open apps and your 50 browser tabs live. On the flip side, ROM, or read-only memory, is permanent. It's like a locked safe containing the unchangeable rules your device actually needs just to boot up in the first place.
We see a really similar, critical distinction when it comes to long-term storage too. HDD versus SSD. Contrast the older, kind of fragile, spinning mechanics of an HDD, a hard disk drive, with the absolute lightning-fast flash memory rocket ship that is an SSD, or solid-state drive. Knowing this difference is huge, because choosing an SSD directly translates to picking a significantly faster, more responsive, and way more reliable computer. It's for sure a real game changer.
All right, let's build outward from the physical machine and move to Section 3, Networking and the Internet. Let's see how these devices actually talk to each other.
Now, what's really interesting about this slide is how networking transforms these isolated boxes into a massive global web. Think about it. When you type a URL, a Uniform Resource Locator, into the www, the World Wide Web, a DNS, or Domain Name System, basically acts as your digital phone book. It finds the exact right IP, or Internet Protocol address. Then your ISP, your Internet Service Provider, routes all of this through your local Wi-Fi. And hey, if you're security conscious, a VPN, a virtual private network, masks that entire journey for you. It's a beautifully interconnected system. To really wrap our heads around how these networks scale up, we can compare a LAN with a WAN. A LAN, which is a local area network, handles the tight, localized data traffic right there in your house or your office building. A WAN, on the other hand, is a wide area network. That is the massive, wide-reaching global highway linking all of those little local networks together across entire continents. So it's a perfect mini-narrative about geographical scale. Okay, let's shift our focus from those physical networks back into the digital stuff. Welcome to Section 4, Software and Programming Basics.
The single most vital piece of software binding this whole shebang together is your OS, the operating system. The OS acts as this crucial umbrella software. It manages all that physical hardware we just talked about, right alongside all your human interactions. Basically, without an OS, your super powerful hardware is literally just a heavy, expensive brick. It can't do a thing.
Underneath that umbrella is a massive ecosystem of programming languages and file formats. While HTML, Hypertext Markup Language, builds the actual visual structure of the websites you visit, SQL, or Structured Query Language, is back there managing the hidden databases running behind them. And applications? They talk to each other invisibly through an API, an application programming interface. But they present everything to you visually through a GUI, the graphical user interface. Oh, and for those finalized, uneditable documents we send around every day, we rely on the good old universal PDF, the portable document format.
Now, when you are navigating the web using all that software, there is one critical distinction you always need to look out for: HTTP versus HTTPS. HTTP is your standard hypertext transfer protocol. So the crucial point here is that single S at the end of HTTPS. That stands for secure. If you're ever entering a credit card number or a password and you only see HTTP, stop right there. Don't do it. That S is vital because it guarantees your everyday data is encrypted and completely safe.
Let's expand our journey to the absolute frontier of technology now. Here is Section 5, Emerging Tech Trends.
Computing has wildly evolved from basic text inputs and mouse clicks, hasn't it? Take AI, or artificial intelligence. Under that massive umbrella is the specific discipline of ML, machine learning, where systems automatically learn and improve from their own experiences. It's amazing. Meanwhile, spatial computing is pushing totally new boundaries. You've got VR, virtual reality, which fully immerses you in a simulated digital environment. And then there's AR, augmented reality, which overlays digital information directly onto the real world right in front of you.
And that brings us to our final payoff. Section 6, Mastering Your Tech Specs. Let's wrap this comprehensive journey up.
If you are looking to build out an even broader personal dictionary, I highly recommend browsing the full guide on Geeks for Geeks or visiting the Testbook Computer Awareness Portal. These are both fantastic resources from our source material today, and they offer some really incredible deep dives into these abbreviations and a whole lot more.
So, by breaking down this massive bowl of alphabet soup into clear, understandable concepts, we've essentially unlocked a completely new way for you to understand your everyday devices. You're no longer just blindly consuming tech, you are actually speaking its language now. So I'll leave you with this final thought. Now that you speak the language, what will you build, fix, or discover next?